Hi all, good morning. Let us focus on classes and objects as a core concept in Java. Java is a pure object-oriented programming language. In this session, we focus on how to design the user-defined classes and how to create the corresponding object, how the methods, instance variables are accessible with the help of object. That is the focus. In Java, the class capital C class is a built-in class available in java.lang package. Class is a built-in class available in Java's language package. Where class small c, a class is a keyword. Class is a keyword in Java. The user-defined classes in Java starts with the keyword class. Class, then this is followed by the name of the class. Class name is the user-defined class name. Similar to that of a C++, right? You try to recall that in C++ class name, then within opening and closing curly braces followed by semicolon. In that, you need to specify the access specifiers: private colon, a public colon, a protected colon. In each of these sections, private colon or public colon or protected colon, you can define the variables said to be the data members of a class. And you can declare or define the member functions, corresponding member functions. You can define the member functions within the scope of class declaration as automatic inline functions using the general form, return type, method name, then return type, function name, parameter list, then within the opening closing curly braces, inside the class itself, you need to declare and define the functions. If not, you can declare a functions inside the class, say return type, function name, parameter list, and the function can be defined outside the scope of the class declaration using the scope resolution operator. Compared to the syntax of a class syntax of C++, here in Java, the keyword, right, class, which is followed by the name of the class name. Then within the opening and closing curly braces, you need to define the members of a class. The first difference from C++ to Java is that in C++, class declaration ends with a semicolon, where in Java, class declaration will not end with a semicolon. So the general form is class name, opening curly brace. Here, the corresponding closing curly brace. It should not end with a semicolon. Because here in Java, here you need to define variables and the methods are going to be defined as the part of the class. Later, we are going to see the concept of abstract classes. So as of now, the general form of a class takes this form: class name, opening curly brace. Inside this, what you have to do means you need to define the variable list. For example, data type 1, instance variables list. Instance variables are nothing but the variables, right? Normal variables. The variables which are declared inside the class are said to be instance variables in Java. Instance variables are nothing but the variable class variables declared inside the class. Second, for example, here we can specify another data type, say data type to instance variables list, etc. Data type n, we can define any of the valid data types supported in Java. Data type n, instance variables list. Can you compare this declaration with that of C++? In C++, what happens? You need to specify the thing, access specifier, a private colon, a protected colon, or public colon. Where in Java here, you need not worry about here a private colon, public colon, or protected colon. Instead, here access specifier right should be mentioned. Access specifier data type 1 instance variable list. Access specifier data type 2 instance variables list. Likewise, access specifier data type n instance variables list. There are three types of access specifiers. They are access specifiers or access modifiers. What are they? Private, public, protected. By default, the class members in Java are set to be public access code. Default access code is public with respect to the same package. This is in Java. What is the default access code in C++?
Private.
What is the default access code in
Private, sir.
private? Yeah. In
Private.
case if you do not specify even private code,
Private.
yeah, private, if you do not specify private colon,
Yeah.
by default the variables and functions are coming under a category private school. Here in Java, you need not specify public data type 1 instance variables list. By default, the members of a class, including variables and methods, are coming under a category of public access scope. So default access scope is public with respect to the same package. Later we will explore, right, what is a package. So that stage you will know what are the remaining access specifiers, how it can be useful, accessible with respect to package. So as far as the class declaration is concerned, you can declare any number of variables in this general form. Following this, you can define any number of methods. Here there is no concept of declaring methods and defining the methods outside the scope of the class, except abstract classes. Later we focus on the concept of abstract classes. So as of now, we just think of the class declaration can have variable declaration and methods definitions. So methods definition means normally the definition takes this general form. Return type, which specifies what type of value is returned from the method name 1. Method name 1 is the user defined name, which represents the name of the method. Parameter list, the parameter list which are defined in, these are said to be hot parameters. Function definition parameters are said to be, we call that, in a function call, the parameters are said to be actual parameters, where in the function definition, the defined parameters are formal parameters. So return type method name 1 parameter list, then method name 1 definition. Likewise, return type 2, return type method name 2 parameter list, then method 2 definition, opening and closing curly braces. Likewise, we can define any number of n methods. Return type, say the last method is method name n parameter list, closing curly braces. This is the simplest general form of a class. Class name. Within this opening and closing curly braces, you need to define the variables using this general form, and any n methods can be defined inside the scope of the class. So comparing this with the C++, their private public access specifiers, the general form is somewhat different. Private colon, public colon, protected colon. Here by default, the main difference is the members of a class. Members means both variables and methods. In Java, the member functions are said to be methods in Java methods. So the collectively the methods and the variables in Java are said to be members of a Java. By default, the members of a Java are coming under a public category with respect to the same package. Where in C++, the default access scope is a private. Second thing, in C++, we can declare a method and defining the method or a function outside the scope of the class declaration. Where in Java, here you need to define the method completely inside the scope of the class, except abstract classes, right? So here you need to follow this general form. Return type method name, parameter list, method definition. define any number of methods here. The third important difference is in C++, whenever a member function does not return a value, there the return type is void. Void is not a mandatory one. Void is optional one in C++. Where in Java, whenever a method does not return a value to a calling place, in that case, the return type must be explicitly specified as void. Say void compute something, or float return x something. Understand or not? So this is not an optional return type, mandatory return type. These are the main differences from a C++ to Java. The important thing is you can ask, what about the main method? So far we have explored so many examples. All those examples involve a main method, static, public, void, main string arguments, then opening and closing curly brace of a main method. You can ask, where is the main method in our general form? Since this is the general form of a class, the general form of a class will not involve a main method, similar to that of C++. In Java, the general form of a class will not involve a main method, not necessary, right? Actually, main method is not included in this user-defined class. Main method is required only when you have to specify main as a starting point of the program. That stage main method is required. Even main can be returned inside the scope of this user-defined class, right? But to avoid the confusions, since object-oriented program modularizes the complex task into a set of modules, set of classes, objects. So what we have to do means try to define one or more user-defined classes like this using this general form. Then at the end of the program, define a main method in the separate class. So inside the main method, in the separate class, you need to create objects for the user-defined classes, and you can call the corresponding or access the methods and the instance variables using the object of the class. So that way, Java follows a pure object-oriented programming style. Classes can be defined right at the beginning, then main method is defined. Inside the main method, for the user-defined classes, objects are created. Objects are responsible for accessing the variables, and the methods are simply the members of a class. Now see how to declare an object in Java. Declaring an object in Java is actually a two-step process. For the class name, you need to define a reference variable first. Class name space reference variable semicolon. Then the second step, reference variable should have allocated a memory using the new operator. Reference variable is equal to new class name. This is the two-step process. So once the new operator allocates a memory, then only a reference variable can have the rights to access the corresponding public members of the class using the dot operator. Similar to that of a C++, here the reference variable is an object. Once the memory is allocated, then reference variable can have the rights to access the instance variables or methods using the dot operator. So declaring an object is a two-step process. This a two-step process can be simplified in a single statement like this. Class name, then reference variable. This is equal to new class name, then semicolon. This is the simplest step in which the reference variable is acted as the instance variable, or you can say the object. Here the reference variable is allocated a memory so that the reference variable can access the corresponding public members of the class using the dot operator. Reference variable here acts as the object. For example, in C++, if sample is the class, we have created an object. For example, sample s1 semicolon. To have the object listed, say sample s1, s2, s3. Where in Java, sample s1 semicolon, then s1 is equal to new sample in the second step. Otherwise, in a simple step, sample s1 is equal to new sample. This is a syntax to create an object in Java. Class name, reference variable or object name is equal to new class name, then parameter list of the constructor, the semicolon. Once the object is created using the new operator, you can access the public members of a class using the dot operator. So similar to that of C++, here just to recall that object name which is useful to access the instance variable, public instance variable. Object name can access the public methods of the class. Object name dot method name. Assuming that object name dot instance variable, object name dot method name, parameter list, semicolon are based on the return type you want to process the returned value. This form, this general forms are accessible outside the scope of the class. So objects are responsible to access the public members of the class since the class can have the access specifiers, a private, public, protected. Object name dot instance variable means what is an instance variable? Instance variable, it must be a public access tool. Likewise, object name dot method name, say semicolon or without semicolon based on the value of its return type we are processing. Here, the method must be a public method with respect to the default access tool, or it should be declared a public explicit. So using this general form, just have one example, say class A, classes 1 EX. Within this opening and closing curly brace, what we have to do is define the members of a class. What are the members of a class? Members of a class means instance variables and methods. Methods must be defined. Methods must be defined here. You can declare, you can define, right, any number of variables, define any number of methods within the scope of the class.
So do we have the
Class
option of
classes
using the
1
scope
EX.
resolution operators?
Here, there is no concept of using a scope resolution operator with respect to two classes. That means with respect to method definition. Methods must be explicitly defined in a C language style. Return type, function name, parameter list, opening and closing curly braces. Even methods may take some local variable declarations. Except abstract methods, right? Abstract classes. Later we explore what is an abstract method or what is an abstract class. So multiple methods must be may be defined here. Then following this, we can define any number of classes similar to C++. Define other classes or other user defined classes similarly. Say class 1, then opening and closing curly brace, class 2, say classes class 2, opening curly brace, closing curly brace, etc. class n, opening curly brace, closing curly brace. Multiple classes may be defined, right, one after another. Finally, right, you need to define one class, say some class name, that must also be placed inside the class. Only thing is that class must define the main method, because main method signifies a program execution, signifies the corresponding beginning of the program execution. So static public void main string arguments here, then opening and closing curly brace of main method, the scope of a class, classes 1 say. Within this, right, what you can do means you can create the object or objects for the user defined classes, whatever you have defined in this file. Say file should be saved as classes1.java. After creating the objects, then access the variables or methods are simply members which includes both instance variables and methods using the object or objects of the class. What can we call here, right, using object name dot instance variable or object name dot method name? For example, here I write obj1 dot method 1. This is valid. Or system dot out dot println, assuming obj1 dot method 2 returns the value to the calling phase. Since obj1 dot method 2 invokes a method 2, assuming that method 2 returns a value to the calling place, so the returned value is received in the highlighted place and can be directly processed in the system.out.println. Or you can write system.out.println.
Your voice is breaking,
What
sir.
you can specify object one, yeah, object one dot instance variable. Object one dot instance variable. Suppose instance variable is x. We can write obj1 dot x so that the instance variable x must be defined as the public access variable. In this way, right, you can access the corresponding variables, instance variables, and the methods of a class using the object. For that, what we have to do means we need to use the dot operator. Same style with respect to C++, object name dot instance variable, object name dot method name. Having any queries in this accessing rules?
Sir, sir, instead of writing the public explicitly for each method, can't we write at once, sir? Like in C++, we'll be writing public and then we'll be defining the methods of the particular class. Can't we do the same thing in Java?
Could not get you. Please repeat.
Sir, actually, we are writing here for every method which we are defining in a class, we are writing public explicitly, no, sir. Like if we are writing a method called main, we are writing public. And if we are writing another methods in the class, we are writing public, no, sir. So instead of like that, like in C++, we'll be writing public and we'll be writing the methods under it. Like we'll be mentioning the access specifier only one time, no, sir. Can't we do the same thing in Java, sir?
Mm-hmm. Yeah, that's what I said. Public is the default access scope. You need not write a public again and again. For example, public method one, public method two, public x int x, public float y, like that. Not necessary. Public is public becomes the default access scope in Java. So that's what here you need not write anything here. That's what here even the general form of a class it misses the access specifier, which means by default the access scope is public. Otherwise, here you need to define private int x, protected int y. Protected have the significance with respect to the inheritance we will explore later. So as of now, private int x or simply int x, that means a public variable. You need not define, right,
Thank you.
using the explicit access specifier, public. Another thing, you have to just recall that I said main method can have the responsibility to call the corresponding user defined methods with the help of dot operator, right? So that's what here main is placed at the end from where we are calling the corresponding methods, and bottom-up programming approach. Another rules are similar to that of C++. Here, for example, classes 1 EX having two methods M1, M2. Inside a method M1, you can call a method M2. Inside method M2, you can call a method M1. So within a class, within the scope of a class, one method can call another method. In case even if it is a private access scope, private method 1, private method 2, because all the methods are defined within the scope of the class. So one method can call another method. That is a concept of nested methods or nested function call, similar to that of C and C++. So with this, we are exploring some examples so that you will understand in a better way the core concept of Java, classes and objects. So I move on to the specific examples. Let us have our first program in classes and objects. Design a Java program to find the area and circumference of a circle. So in this case, what we have to do means we need to define one user-defined class. Class circle. Here circle is a user-defined class. User-defined a class. Let us follow the general form of a class declaration. Class name, then opening curly brace. Then what we have to do means to define the instance variables. Here the instance variables are area and circumference. These are the floating point instance variables. By default, these instance variables belong to a category, public category. All these instance variables are coming under a category, public category. So following this instance variable declaration, you are defining some methods. For example, void compute. You have to notice that what is void. Void is a return type. This is a method name. This is a formal parameter list where the parameters mentioned in the method call are said to be actual parameters, actual arguments. Here, formal parameter is empty, which means that we are not passing any actual parameters in the method call of compute. And void indicates that the method compute finds something and it will not return a value to your calling place. That is the meaning of void. Void is here mandatory one. Then area is equal to, we have written a formula, area is equal to pi r square. And what is this 3.14159? By default, this is a floating point variable, floating point quantity. We need to signify this is a double quantity. By default, a floating point one. By default, floating point quantities in Java results in a double value. So to signify this is exactly a floating point type, you need to append a variable f, right? Then circumference is equal to, we are computing 2 pi r, 2 pi r. Then we have closed the method void compute. Then void display. Inside this, we are defining another method. We would like to display the contents of area and the circumference. System.out.println area is equal to plus area, then circumference is equal to plus circumference. So in this example, we have defined two methods. One is compute and another one is display without any keyboard interaction, assuming that the values are initialized through the main method, or initialization can be done inside the method definition itself. This is the complete user-defined class circle. So just to think of the ADT, abstract data type, circle as the abstract data type, user-defined class, which introduces the public access variables, instance variables, are area, circumference, and we have defined two methods, compute, display. What about the memory allocation? Whenever one object is created, say C1 as a circle object, C1 occupies its own memory. The contents of object C1 are the corresponding instance variables of the class, similar to that of a C++ language. Here, R, right? Public instance variable, area, public instance variable, circumference, public instance variable. So when allocating an object, say C1, C1 allocates a memory to these floating point instance variables, R, area, and circumference. Creating the second object C2, since objects are having the important property, identity property, C1 object is completely different from the C2 object. So when allocating a memory for C2, C2 allocates memory for R, area, circumference separately. Likewise, C3, C4, etc. Because objects are occupying memory addresses, and each object is completely distinct from other object because of identity property. Identity property distinguishes one object from another object. Hope you understand. This is the complete user-defined class with instance variables declaration and two methods declaration. Next, if you want to write, as I said earlier, you can also define the main method after a display method, right? But to avoid the confusion, it is a good practice to define the user-defined classes separately and the main method separately. So following this class, user-defined class circle, I do like to define a class in which I do want to define a main method. So class, say the class name is classes2, then within this I define the main method. Public static void main string arguments. We are creating the object, say circle C1. C1 is equal to new circle. One object C1 is created. Second object C2 is created. C2 is equal to circle, C2 is equal to new circle. Now have a look into these instance variables, R, area, circumference. Since we need the radius as the input, so I am initializing the radius through the object. And important thing, R, area, circumference by default public access to anywhere you can access anywhere you can access these instance variables. That means only within a package. So as of now, right, we are writing accessing everything in the same package. Later we will explore the concept of packages. So as of now, these public instance variables can be accessed inside the main. So C1 dot R. What is R? R is the public instance variable. Since C1 is an object, the corresponding memory is allocated. C1 dot R is equal to 2.5 F. Then C2 dot R is equal to say 5.7 F. C1, C2's content, say the radius content R gets initialized. Then C1 dot compute. Following this, we are calling the C2 dot compute. Then C1 dot display, which displays the contents of area and its contents of its area and the circumference. Likewise, C2 objects, area and the circumference are printed. Let me run the code. Java C classes 2.java. Closing bracket should be removed. Okay, Java C classes 2.java. Then Java classes 2. First, it prints the area and the circumference of object C1. Second, it prints the area and the circumference of an object C2. Having any queries in this example?
Sir, can't we declare that pi as a constant variable global?
One user-defined class with some. Yeah, if you want to declare, you can also declare, right, using final variable, final float, final double constant, right? Pi is equal to 3.14159 as semicolon. Later we explore in inheritance the usage of final keyword. Any other queries? Okay, I move on to another example. In the previous example, we have only one class circle in which we have computed the corresponding area and circumference, right? This is the actual code. Class circle, instance variable declaration, then void compute and void display. This is the code that we have seen in the previous example. Additionally, we do like to define another class rectangle. How is it possible? Similar to C++ style, one after other, we define the corresponding classes. Class name, definition is over. Then second class is rectangle. For example, here I have defined some instance variables, length, breadth, area, and a circumference. Later we define, right, the concept of inheritance, how to optimize the number of variables and methods. Code optimization using inheritance. So just to think of a rectangle is one independent class having some instance variables and the methods are declared, defined, right? Void in data. Here the method takes parameter. Previously, the methods uh, are not taking any parameters. Here, in data is a method which takes two double type parameters. So when calling the in data, because Java is a strictly typed language, you need to pass exactly two parameters, and the two parameters must be of double type. And then void compute rect, which finds the area and the circumference of a class, say a rectangle. Then displays the computed area and the circumference. Then inside the main method, say inside the classes 3, I have created objects of a circle class C1, C2. C1, C2's area and the circumference are computed and those values are printed. Then for rectangle class, so two objects are created, say R1 and R2. The objects R1 and R2 are initialized using the in-data method. Since the in-data takes two parameters, here the parameters are formal parameters. You remember the corresponding name. This is very important. Similar to C, C++, Java. Formal parameters. And the parameters that are defined in the actual method call, function call, are said to be actual parameters. 2.5 and 0.5 are by default double type values, floating point double type values, which are passed as the actual parameters to the method to in data. Here in the left to right order, right? First one 2.5, second one is 0.5 are assigned to the formal parameters x and y, and in turn the formal parameters x and y are used to initialize the instance variables length and breadth of rectangle class. Length is equal to x, breadth is equal to y. Then we have called r1.compute rect, the corresponding method of rectangle class, then called r1.display. Likewise, the second object R2 is created, then R2's circumference and area are computed, and the values are.
Sir, can we have the constructors in Java programming language?
Java C. A constructor is possible. You wait for a few programs. After that, we explore a concept of constructors, parameterized constructors. In this example, we have created two classes, say a circle and a rectangle, and two objects are created for each. Then we have computed their area and rectangle, and the corresponding values are displayed. Having any queries in this example?
So instead of creating the objects inside the main, can't be declared outside the main?
Just understand this. Outside the main, where?
Below class 3, sir. Like
Outside the main means where? Because in Java,
below class 3, sir.
in
Like
class, before class,
before classes 3, before that public static void main, sir. Because
before that where? At this place. I am pointing the marker here in this place.
no, sir. Classes 3, that curly brackets in the
Tell
first
me
line.
exactly so that I will resolve your doubt. Here.
Yes, sir.
You do want to
Yes, sir.
define here. Am I right?
Yes, sir.
This is not possible because here, right, if you are writing something, again you are violating the concept of this class declaration, because class name, opening curly brace, closing curly brace, in which user defined instance variables and methods must be defined, right? In case if it is a main method, no problem, as we did earlier, main method is defined. But here if you are writing any executable statement, even system.out.println or assignment statement, object creation, everything, right, will result in the violation of a class syntax in Java. This results in compile time error, right? You try to check that. And another thing, any executable statement inside the class declaration must be placed inside the part of a method definition. For example, here length is equal to x. As you said now, length is equal to x cannot be given outside the scope of the method. For example, in between these two methods, can we write any executable statement here? This results in error. X is equal to something. This results in error. Because this is an executable statement, this will be a part of a method definition. This is very important. Another thing here, right, variables can be declared. At the same time, if you want to initialize the values of variables, is it permitted? Understand my question? Can I initialize r is equal to
No, sir.
something here? Float r is equal to something? No, why?
Repeat.
It's perfectly valid. By default, some garbage values are stored. You can override the garbage values by setting some initial values. Float r is equal to say 2.5f. That is perfectly valid in Java. You can initialize the variables in the declaration statement itself. But this should be compared with the C++. Very important difference. In C++, the data member which are declared inside the class cannot be initialized in its declaration statement. Say class circle, assuming that this is a part of C++ code. Class circle, assuming right float r as a private scope, float r is equal to 2.5. That is not permitted in the C++, because when you declare the data member inside the class and in a C++, you need to declare only the variables. If you want to initialize it, that can be explicitly done with the help of constructors or with the help of some user-defined member functions. Where in Java, when you declare a variable, that stage itself, you can initialize some value. Let us try, right, in the same example. Say float r is equal to 12.5 f. 5 save. Class name is classes 3. Yeah, perfectly valid. And we are running the code. Say class Java classes 3. It's okay. Understand? This is another difference from C++ to Java. In C++, the corresponding data member should not be initialized in its declaration statement. Directly, that cannot be initialized. Say data type variable is equal to value semicolon is not permitted as the part of a class. Where in Java, the instance variables can be initialized inside the scope of the class, or simply instance variables in Java can be initialized at the declaration time. Having any queries? Okay, I move on to the next example. Mostly tomorrow, right, we will discuss the concept of constructors. Now we are moving to the fourth example. In this example, we do like to discuss how one object can be assigned to another one with respect to instance variables, and what will be the effect whether a copy of the reference is made or copy of new object is made. That will be a basic question. Just have a look into this example. Class rectangle. In the rectangle class, we defined variables. length, breadth, area, circumference, and methods compute, rect, and display. Right, the same as that we have done here. Now look into this main method. Suppose class is 4. Rectangle, here we have created an object R1. Rectangle R1 is equal to new rectangle. R1's length and breadth are explicitly initialized. This is valid. Why this is valid? Can anyone explain me? R1 dot length is equal to 20.0. But in the previous rectangle class, I think we have used some actual parameter values. Using the actual parameter values, we have initialized the values. Now the highlighted statement is valid, which initializes the content of object R1. How or why?
Sir, because
They are
length and
public, sir.
breadth are the instance. Because length and breadth are the instance variables of rectangle, no, sir. So they are by default they are public. So
Very
we
good.
can access the public variables.
Very exactly. Okay. Length and breadth are instance variables of class rectangle, and they results in a default access code public. So we need not define a method, right, to make further initialization. Perfectly valid. R1 dot length, R1 dot breadth. Then the compute rect, right, here I have given one message. R1 is constructed, R1 dot display. The contents of R1 are going to be displayed. Likewise, second object R3 is constructed. The values are changed. Then have a look into the third object, rectangle R3. We are applying a two-step process, means rectangle R3. In the subsequent step, we need to define R3 is equal to new rectangle constructor. But here, instead of having that second step, I like to define R3 is equal to R1. Have a look into the statement, very important. What is R3? R3 is as of now a reference variable of a class. Whenever a variable, class variable, is not allocated a memory, it can be termed as the variable, right? The variable is termed as a reference variable in Java. A reference variable can be created for interfaces, classes, right? Interfaces we will explore later. How to create a reference variable for an interface. Here, as of now, to create a reference variable for a class, simply use this general form. Class name space reference variable semicolon. So once a reference variable is created, in the subsequent step, if you try to write, I write it in a command line. R3 dot, what is the method of R3? Say display. One method of R3. If you try to call R3 dot display, this results in error. Can you point out why the error is?
Because R3 is it is just a reference variable, sir. But the object is not created, sir.
Memory is not allocated for R3.
Yeah, very good. Yeah, very good. Memory is not yet allocated to the reference variable R3. So subsequently, in case if we have used R3 is equal to new rectangle, perfectly valid. R3 dot display, if and only if display is a public access specifier. Now this is an error, but indirectly, right, given another statement, R3 is equal to R1. So in that case, what will happen means a reference of R1 is assigned into R3. That means here, how will you think this assignment statement R3 is equal to R1? What about its memory allocations to both R3 and R1?
Sir,
Can you predict anything from this highlighted statement?
sir, can R1 is a R3 is an alias for R1, sir. Like we can access the R1 object with the name of R3 also, sir. So there will be no separate allocation of memory for R3.
Yeah, yeah. In C++, you might have seen this concept. Let me make it in a command line. Suppose float x, then float ampersand y. Remember that? Float ampersand y is equal to x. Now what happens? X is a floating point variable. Y is also a floating point variable. Writing float ampersand y is equal to x means both x and y are pointing the same memory location. So x is an alias or y is an alias of another variable. So x is an alias of y or y is an alias of x. Both x and y are pointing what one? Same memory location. Likewise here in Java, if you assign same memory allocation. If you assign one instance variable, one reference variable to the object R3 is equal to R1, actually R1 is the object. When R3 is equal to R1 means, do not think that R1 is copied into R3 by creating a new object R3. So clearly understand, no separate memory is allocated for R3 and R1. Content wise, memory location wise, both R1 and R3 are pointing the same memory location. So simply write the concept is R1 is, or we can say R3 is an alias of R3 is an alias of what one? R1.
R1.
Both R3 and R1 are pointing the same memory location. R3 and R1 are pointing the same memory location. So here R3 is equal to R1. So content wise, R3 and R1 are pointing the same memory location. So R3 dot display simply prints the content of R1 dot display. Both are same, right? Since R1 has already been initialized with 20 and 5, so writing R3 dot display means the corresponding initialization is taken place with 20 and 5. Understand? Say yes or no.
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
separate memory is allocated for R3. R3 is an alias of R1. Both R3 and R1 are pointing the same memory location. So writing the diagram for the object R1, you just think of one rectangle is drawn. Inside that rectangle, two variables are mentioned. One is length and another one is breadth. For example, length memory address is 5000. What are double? Double occupies 8 bytes. So if this is length is at a memory address 5000, breadth is at a memory address 5008. I am not explaining the pointers concept, but normal addresses concept. So 5000 memory address of length, 5008 memory address of a variable breadth. Same memory address 5000 and 5008 with the same initialization 20 and 5. R3 is pointing. R3 is an alias of R1. Now have a look into this statement. Here, subsequently, I am setting R1 is equal to null. Just think of the comment is removed. This comment is removed. I've seen this code. After setting rectangle R3, R3 is equal to R1. Subsequently, right, I am setting R1 is equal to null. Once you set null to the memory allocated variable, say object, then subsequently the object will not point the corresponding memory location. That means subsequent statement with using the dot operator will result in a compile time error. So R1 dot display means this results in a compile time error because R1 is pointing null, right? So have a look into the running of the code, right? Compiling the code, eliminating this command line, you will get null pointer exception, right? Null pointer exception. Exception means a runtime error. So during the runtime, you will face that, not in a compile time. Setting R1 is equal to null and R1 dot display means just check out. This results in a runtime error, null pointer exception. Null pointer means again there is no pointers concept in Java. We are pointing a nullable reference R1 to access the corresponding display. So R1 dot some variable, R1 dot method name is an illegal one. That's what null pointer exception will be the result. You try to check that. But anyhow, I commented out this comment the error message. So setting R1 is equal to null. Subsequently, R3 is equal to R1. I am calling R3 dot display. Now what will happen? Can you predict here? What is the role of R3 dot display?
Error.
So error. So far what we have discussed, R1 is a memory allocated object. Yes. After R3 is equal to R1, R3 is an alias of R1. Yes. Both R1 and R3 are allocated the same memory. Yes. Next, R1 is set to null. What is the effect of R3?
So it will display the contents of length and breadth as
The thing is a different. Two names. Yes, the thing is different. R1 and R3 are two names pointing the same memory location. One name has been just eliminated. That is the meaning. R1 is equal to null means, right? Still R3 is valid here, valid memory location. So R3 dot display means there is no problem. Suppose, right, you just think of these three lines are commented, right? Highlighted lines are commented, and ignoring, right, these comments, having only the first statement. R3 is equal to null, R1 dot display. The meaning is here, after this rectangle R3, R3 is equal to R1, I am setting the memory allocated object, actual object R3. Sorry, actual object is R1. R1 has been set to null previously, right? So R3 is valid. Now, in case, suppose R3 is set to null, what about R1?
It will display the
Just alias, right? A name has been set to null. Yeah, R1 is valid here. Only the name is invalid after setting null. We cannot access using that name, object name. But which will not set the memory location to null. Corresponding R3 memory location is not set to null, right? But the name R3 is equal to null means R3 becomes a nullable reference, so that using R3 we cannot point any valid memory location. That's what R3 dot display, that results in error. But R1 is an alias of that memory location. Memory will not be deallocated if you set one object or reference variable to null. That is very important. Memory deallocation is not possible by setting a null, but access is invalid. Another one, the same statement, rectangle R3 is equal to rectangle R3. Subsequently, we have called R3 is equal to R1. In C++, you might have studied, right? This will invoke the corresponding copy constructor, right? Here there is no that concept, right? A copy constructor, but later you see constructors. This can also be written in a single line. Rectangle R3 is equal to R1. To illustrate that, I created another object, say R4. Rectangle R4 is equal to R2. Another possible way of calling a copy constructor in C++. So in that case, the object R4 is constructed. Now what will happen? R4 and R2 are pointing the same memory location. R4 is an alias of R2. R4 is an alias of R2. What is R2? R2 is an object which has been constructed earlier. So using that, you want to construct an object R4, but no separate memory is allocated to have R4. Instead, R4 and R2 are pointing the same memory location. Subsequently, right, I have two queries. Since R2 and R4 are representing the same memory location, I do want to change the length and breadth values through any one alias. Then we do want to check the effect of another alias. Say R4 is updating through R4. R4 dot length, R4 dot breadth, then R4 dot compute, R4 dot display. This is the effect, changing of effect through the object R4. Then calling R2 dot display, what will happen? What about the effect of R2 dot display? R2 and R4 are same, right? Alias. If you are changing R4 dot length means, what about the value of R2 dot length? R2 dot length is also 1000. R4 dot breadth is equal to 500 means R2 dot breadth is 500. R4 dot compute rect, here R4 dot display. So in that stage, what will happen means R2 dot display, R2 dot compute rect, R2 dot display. The same effect is made. Hope you understand. You are changing the content through any one reference, but the values are completely affected in the same memory location. So here just to think of R2.display, before that R2.computeRect is called, then R2.computeRect, I missed that statement, R2.computeRect, then R2.display. same values are displaying here because R4 and R2 are pointing the same memory location. So instead of this, right, for example, I do like to update a variable R2 using R2.length, R2.breadth, R2.compute. Then I have to call R2.display. Then R4.compute R4.display means R4.compute I have missed that R4.compute followed by R4.display. That is same as R2.compute and R2.display. Hope you understand. Why means R2 and R4 are pointing the same memory location. So you are changing the values through any one alias, and if you access the variables using another alias, updated values are taken place. So the changes made in any one alias will reflect in another alias in case of these assignment statements. But in case of setting the alias name or object name to null means another alias is still valid. Another alias will access the corresponding instance variables or methods. Memory will not be deallocated by setting the object name is equal to null or reference variable is equal to null. So try to understand how to create a user-defined class in Java, then understand what are instance variables, how to define methods, and the general form of a class, and the accessing rules of classes and objects, how the user-defined objects are created in Java, how the objects are going to access the corresponding instance variables or methods using the dot operator, right? And the style of writing the classes in Java, class, right? One class name followed by another class, define n classes, and try to write a main method which is defined in a separate class. Then define the objects, call the corresponding instance variables or methods, right? Then call the processing statements in the sequential order, and understand the effect of setting instance variable or an object to a nullable reference. You try to run a code by removing these comment lines, right? And try to understand how the runtime error is reported when calling this one R1.display. Having any queries? If you have any queries, you can ask. I shared the code in the Google Classroom. Any queries? Okay, thank you very much. We will discuss in the next session.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.